Hi. So we've done till now all the oral anti-diabetic drugs, right? So those were the drugs which are given by the oral route, right? So now we're going to talk about insulin. Now this insulin actually is mandatory or is the drug which is given in insulin dependent diabetes mellitus. That's type 1. उसमें देते हैं insulin है, right? Because there's no insulin over there. Because the drugs जो अगर हम देंगे वहाँ पे they actually going to increase the insulin sensitivity or increase the insulin secretion, but जब insulin है ही नहीं तो drugs can't be given in those cases, so therefore we give insulin in those cases. But insulin in type 2 is also given in case the drugs are no longer capable of maintaining the blood glucose levels within the range, right? So let's see what is insulin all about. So we are going to see how is insulin secreted and what are its important actions in this particular lecture. So insulin, the structure, it is made up of a A chain. This is an A chain and this is a B chain. And it is linked together by a C-shaped structure. इसको हम कहते हैं C-peptide. Okay, so this is A chain, B chain linked together by C-peptide. So this is released from this insulin is released from the beta cell of the pancreas. So about 50 units are released in 24 hours. उसमें से जो 50% है, that goes into the portal circulation and that is degraded. Portal circulation में और वो फिर हो जाता है degrade. The rest 50% will enter into the systemic circulation, right? Or systemic circulation में जाएगा and it will perform its effects. This is how it is going to do. Then secretion of insulin, how is it triggered? What are the factors which can increase the secretion of insulin? The first most important factor is glucose in the diet. So whenever we have glucose, we take in glucose, हम खाते हैं, carbs and glucose is released as a primary, substance which increases the release of insulin. So we've already done it before when we did the mechanism of action of sulfonylureas, that this glucose, so this is G's glucose, is taken up into the beta cell. This is the beta cell of pancreas. With the help of the GLUT, glucose transferase enzyme, it takes up the glucose inside. This glucose gets converted to G6-phosphate and there is release of energy, that is the ATP. And ATP acts on the ATP sensitive potassium channels and it is going to block this channel. अब जब channel block होता है, normally क्या होता है, potassium is moving from inside to outside. But when we block this channel, potassium can no longer move to the outside. So potassium will start accumulating here inside. And you see the positive charge is going to increase. So whenever the positive charge increases inside, it's called as depolarization. So potassium leads to the depolarization. It will trigger the calcium ions or open the calcium ions and more calcium is going to get inside. And when the calcium gets inside, there are insulin which is present inside these storage granules and it is going to lead to release of the insulin from the storage granules and this insulin enters into the circulation. So this is how glucose triggers the release of insulin. Okay, so हमने किया था sulfonylureas, they will also act here, meglitinides also, they act at this point to block the ATP sensitive potassium channels, right? So this is the primary let's say stimuli for release of insulin. There are the other factors which can also cause release of insulin. हमने किया था incretins like GLP-1. They also cause release of the insulin. Then you can say glucagon. Glucagon from the alpha cells of pancreas. They also stimulate the release of insulin. Growth hormone, thyroxine, etc. also stimulates the release of insulin. Hypokalemia, decrease in the potassium levels, inhibits insulin release. So when there is, this is very important point, decrease in the potassium levels inhibits insulin release. Cholinergic transmission, cholinergic or vagus stimulation जो होती है, cholinergic transmission, that is the vagal stimulation, or the beta receptor stimulation, that leads to also the insulin release. So these are few factors which can cause the release of insulin, right? Now, mechanism of action of insulin, what you should know that, we have already done in the pharmacodynamics, different types of receptors. So, जो insulin का receptor होता है, वो होता है tyrosine kinase receptor. Tyrosine, enzyme linked receptor, जिसको हम कहते हैं tyrosine kinase receptor. It's an enzyme linked receptor. So, it is transmembrane in structure, मतलब it passes through the membrane. आधा हिस्सा ऊपर है, that is the alpha subunit, and the beta subunit is below into the cytoplasm. और जो beta subunit है, it has an enzyme attached which is called as the tyrosine kinase. So when insulin is attached to its receptor, this is the insulin. When it attaches to the receptor, what happens? There is, activation of this receptor. So this tyrosine kinase gets stimulated. It gets phosphorus attached होता है, उसको हम कहते हैं phosphorylation होती है इसकी. So that is stimulation of the tyrosine kinase. It gets phosphorylated, and these two जो हैं units of receptors, they start coming together. इसको कहते हैं dimerization. Two units, dimer is formed. They come together, and then they are going to, when they come together, they are going to activate certain enzymes. ठीक है, certain enzymes and the proteins in the cytosol, in the cytoplasm. So when they will stimulate these enzymes in the cytosol, and the certain proteins are formed, so that leads to the response. So all you have to remember is they act on what type of receptor? Tyrosine kinase linked receptor, and these are enzyme linked receptors. The insulin binds to the alpha subunit outside, not the inside, and there is activation of these receptors. Ultimately the response occurs. This is, you should know, that is what. Then the immediate response क्या होता है? Three major organs जिसको insulin target करते हैं, the target organ for insulin are liver, muscles and the adipose tissue. So remember, these are the three major organs, and हमें को ultimately हमें क्या चाहिए? Decrease in the glucose levels. So that is what is insulin going to do. So on the liver क्या करेगा इसको? It will inhibit the formation of new glucose. So it will inhibit the gluconeogenesis. ज़्यादा formation नहीं होने देगा, neogenesis, and it will inhibit. So यहाँ पे glycogen is stored. Let's say this is the glycogen molecule. These are so many glucose molecules together, they are glycogens. So अगर ये breakdown होगा ऐसे करके, then this is the glucose which can be released. So what it is going to do? Inhibit the breakdown of glycogen, and that is called as glycogenolysis. ठीक है? So it inhibits the gluconeogenesis, it inhibits the glycogenolysis. ठीक है? And it promotes the glucose uptake. Simple on the liver. Then let's do the muscle. Muscle are these the peripheral tissues which need to take up glucose. ठीक है? So it will promote the uptake of glucose into the muscles, and the utilization, of course, of the glucose. So it will be utilized. Then it will promote in the muscles formation of glycogen. So glycogenesis. It will lead to, जैसे glucose अंदर आएगा, ठीक है, and it will be stored in the form of glycogen. It will promote it. Also it promotes the protein synthesis. So जो भी amino acids है, it is taken up and proteins are formed. So amino acid is no longer available free कि वो जाके liver में जाके glucose बनाए. So they are utilized in the formation of protein synthesis. This is important. Similarly in the adipose tissue also, और ये glucose अंदर कैसे आता है? There is glut. Glucose transporters are present. It stimulates that. So here also it is going to, through the glut, it is going to stimulate the glucose uptake. Glucose uptake. ठीक है? That it is going to do. Then it is also going to stimulate the lipogenesis or formation of lipids, ठीक है, and inhibit the breakdown. ठीक है, it will lead to triglyceride synthesis. Triglycerides are formed, breakdown is prevented, so no more ketone bodies and all their forms so that they can be utilized by for formation of the new glucose. So these are the important actions, and on the vascular endothelium also it will prevent any increases the VLDL uptake. तो जो important जो हमने चीज़ें इसमें देखनी है वो क्या है, हमने यही देखनी है कि ये हमें मोटा मोटा पता होना चाहिए कि ग्लूकोज के लेवल्स बॉडी में ब्लड में कम कैसे हो सकते हैं. या तो ग्लूकोज फॉर्म होना कम हो जाए, एक्सेस न्यू ग्लूकोज, either the breakdown of glycogen stops और जो peripheral tissues हैं उसको ले लें. So this is what insulin is going to do. ठीक है, अगर liver, बस remember that insulin acts on MAL mole, muscle, adipose tissue and the liver. Muscle and adipose tissue, mostly similar functions, increases the uptake of glucose in them, increases the utilization of glucose in them. Muscles में protein synthesis ज़्यादा form करता है, adipose tissue fat है उसमें lipogenesis होएगी, fat ज़्यादा बनेगा, and decreases the breakdown of protein and decreases the breakdown, inhibits the breakdown of fat. So it's an anabolic. ठीक है, it leads to formation of things, not breakdown. It's an anabolic hormone. And on the liver, it will inhibit the gluconeogenesis, inhibit the glycogenolysis. So just simply nothing much to mug. हमें सिर्फ ये पता होना चाहिए ग्लूकोज ब्लड में कम कैसे होता है, वही चीज़ें इसने इंक्रीज करनी है. फिर इसके लॉन्ग टर्म इफेक्ट्स हैं, देखे गए हैं कि इट हैज़ एन एंटी इन्फ्लेमेटरी इफेक्ट ऑल्सो एंड द वैस्कुलर इफेक्ट ऑल्सो. But these effects are the most important to remember, right? So these are the effects of insulin. So क्या होता है, insulin is secreted from the beta cell of pancreas, right? That we should know, and it is secreted 15 minutes to 24 hours कुछ हो जाएगा, destroy in the peripheral tissue, in the portal circulation. Some will be utilized in the systemic circulation and some is released based धीरे release होता है, कुछ postprandially release होता है. That's what the insulin role is. Secretion, most important secretion stimulus is the glucose, please remember, and the rest are the GLP, glucagon, etc. But this is the most important, so remember this because this is how the insulin is released. Mechanism, remember the receptor. It has works on tyrosine kinase receptor. The name of receptor is important. No details nahi puchte. Only it acts on the alpha subunit, and therefore the tyrosine kinase gets activated, and therefore the response mainly hota hai, and this immediate response occurs through glut and mostly through the glucose transporters. यहाँ पर देखोगे उनकी expression increase हो जाती है. So wherever they are, जब भी glut होगा वो glucose को transport करेंगे from outside towards the inside of the tissues. That's what their main role is. ठीक है? So inhibits the formation of new glucose, inhibits the breakdown of glycogen, and increases the utilization of glucose. Okay, that's the most important thing to remember. So this was generally about what insulin is. Now in the next lecture, we are going to talk about different types of insulin and what is different in these different types of insulin, and what are the various side effects which can be seen with insulin when they are used clinically. Right, so this is introductory lecture to the insulin. So okay, meet in the next lecture. So till then, take care, study hard. Thank you so much.